This is a video explaining how to use the program Elluminate, which I've been using for online office hours. So what you're going to see in this video is it's from a 2-hour session I did in Elluminate, and I increased the playback speed and I cut certain parts to make it a lot shorter so you can watch it. So this video feed you see of me, that's when I was doing the office hours. And I didn't use any volume when I did the office hours, any narration. So this narration is done after the fact that you're hearing now. All right, so let me just narrate when relevant. This is a multi-particle problem here, and some of the students were confused about why there would be a difference between the total translational energy of the system, or the translational energy of the system and the total energy of the system. Well, it happens to be that the total energy in this case is greater because the translational energy does not take into account the relative kinetic energy. So here you saw that I just made a simple diagram to explain that point. I used the drawing tools that you can see to the left of the whiteboard on Elluminate, and then I drew a little simple picture of two equal masses heading towards each other, and of course the center of mass is not moving in that case, so the translational energy is 0, but there's relative motion, so the total energy is not 0. Okay, and here you can see in the text window I'm talking to students. Okay, so that was one example of what you can do with Elluminate. So in this question, a student asked about black absorption lines. So why is it that you don't get a black line for all the possible transitions between states? So I just drew 3 lines here, and then I used the text tool in Elluminate, and then I drew 3 transitions. But I used a different color, notice, to draw the red transition, which is not allowed. Sometimes it's good to color your text also, so you'll see what I did with text color here. I had made a mistake there because I used the wrong color. Okay, well that's what I meant to do. The violet arrows were allowed and the red one was not allowed. And you can see me explaining that to the student in the text box here. Notice the students at the top left have little highlight boxes that turn on, the yellow boxes to the right of their names, and that indicates that they're typing something. You can also see the Q, those are the 5 hands raised, and they can click that little hand button on the left-hand side of the screen to raise their hand. That's how I know the order in which to answer their questions. Okay, here's another multi-particle question where you have 2 blocks connected by a spring. And the student asked about a different part that I hadn't snapshotted in before. So I went to my browser, found the place where she was asking about, and then I snapshotted that into the problem, into the whiteboard. Here I'm looking at the answer key so I can figure out what the answer is before I start typing. I know it might sound like cheating, but you'll be more efficient if you know what the answer is before you start trying to explain it, because it's going to take you a few moments to figure it out. If you can speed that process along, then that's a good thing to do. Okay, so notice I'm asking her a question. I don't always just tell the answers to them. I want them to think a little bit on their own. So if the student is really struggling with the problem, then you can give them more. But in this case, I thought maybe I'd ask and wait a sec, see what she comes up with. And then a different student there, named Mike, figured out the answer. We should look at the work done on the real system. Okay, one guy got disconnected, so that's. Notice that I'm using a pointer icon. That hand on the whiteboard draws everyone's attention to the particular question that we're looking at. That's a good way to focus everyone's attention. You might have, I have 13 people in the room right now. Everyone needs to know what we're talking about so they can all get something out of it, because there's quite a bit on the whiteboard here. All right, here I'm using the equation pane. You can see on licks. And that's the work energy theorem that I just typed. So they want to use that for the real system here. Okay, then Mike brings up a good point. He says, what about the potential energy? Because on my formula on licks, I only mentioned that the kinetic energy changes as a result of work done on the system. But I made a mistake, actually, which happens. And in this question, there's more types of energy than just kinetic. So I really should have said the total energy. So I made that change you can see over in the licks window. So usually I try to just go through one by one if a lot of people are confused. Well, I asked if everyone understands that third part, we'll skip it. But then I see a flurry of responses that they don't understand the third part either. Okay, so here I'll do some explaining. Yeah, sometimes you just need to do some conceptual explaining. Not just, how you get the answer, but what is this about? So at some point, it's a good idea to try to summarize what you think the whole homework is about, if there's any unifying theme. That's what I'm attempting to do here, explaining how the point particle system is related to the real system. And it looks like she figured out the answer to her own question there just by thinking about it. That's what you want to see. Okay, enough of that one.